Okay, we have section 2.1, exercise 24. This one looks good just because it has a square root of x in it. So we have f of x equals 4 over the square root of x. And so if I want to find f prime of x, that's the limit as h goes to 0 of f of x plus h minus f of x. Now see, this is something you should not get wrong by the end of this section, is what is the definition of a derivative? You know, this limit right here, it is always this limit. Now you can write it some other ways, but hey, this always is a perfectly good way to write it, and so you just do it this way every time. Now, so this is the limit as h goes to 0. Now here we have 4 over the square root of x plus h, then minus 4 over the square root of x, all divided by h. Now, so here, you know, all I can come up with is get a common denominator. Multiply top and bottom here by square root of x, top and bottom here by square root of x plus h. And then we'll see what happens after that. So, you know, so some of this, you just get into a lot of algebra. So we have 4 times the square root of x minus 4 times the square root of x plus h. Oops. And this is all over the square root of x times the square root of x plus h. Now that's all over h, which means if I invert and multiply, that's 1 over h times this, so I'm just going to put my h there. Okay, now the top, there's not a darn thing I can do with that yet. Okay, so that's the thing is, you know, okay, I got a common denominator, that's something I could do, but unfortunately I cannot combine those. I could pull a 4 out of it, but then I'd still have the square root of x minus the square root of x plus h. And the problem is, if I simply do a direct substitution of h equals 0, well, I get 0 on top, 0 on the bottom, 0 over 0, indeterminate form. So what I do, you know, our nice little trick when we have like h over h is, you know, makes 1. We can do the same thing sort of in reverse, is I'm going to take that 4 out, and then I've got the square root of x minus the square root of x plus h, and all over h times the square root of x times the square root of x plus h. Now what I can do is I can multiply top and bottom by the square root of x plus the square root of x plus h over the square root of x plus the square root of x plus h. So I do that, and the reason I do that is that this is the difference of squares. And so with that difference of squares, I end up, oops, there's a 0 there. The limit as h goes to 0, I have that 4. But now when I multiply this, I have the difference of squares, which makes that the square root of x squared, so that's x, minus, put it in parentheses, the square root of x plus h squared, which is x plus h. So that was wonderful. And then I have my h, and on the bottom I have this nasty looking stuff, x plus h there, square root. But the nice part is, once I do this simplification here with the x minus x, I'll be able to factor the h out, and the bottom here I can do a direct substitution. So even though it's yucky looking, it doesn't really matter. So again, see, that's x minus x. Now you got a negative and an h there, so when I factor out that h, limit as h goes to 0, I have h over h, and then the limit as h goes to 0 of negative 4. And the bottom here, I got this square root of x plus h, and then times square root of x plus square root of x plus h. Now though, I can do, this is 1, and I can do my direct substitution over here, and so I get minus 4 over. Now, I put in h equals 0, so that disappears. So here I have the square root of x times the square root of x, so that's x. And then here I have the square root of x plus the square root of x, so that's times 2 times the square root of x, which is both really ugly and I can reduce it anyway. And so I can write this as minus 2 over x times the square root of x. Now I could also write it as minus 2 over x to the 3 halves, or I could write it as minus 2x to the negative 3 halves. Any of those are fine. They get us the answer. But there is our derivative. A lot more algebraic work on number 24, but we can still get it done there.